And welcome back to Mrs. Riley's Maths videos. I'm looking here at coordinate geometry of the circle, and this is probably part of the hardest part for some people on coordinate geometry of the circle. It's where we're finding the point of intersection of a line and a circle, and the reason it's hard for some people is because it's an algebra based type question. Okay, so let's just talk through what it looks like on a graph before we start the algebra part. So if you notice, we have a circle here. Let's call it K, and the circle K, not the shop or the petrol station, but the circle. If you notice, it's got center 0, 0, and it's got a radius of length of 5. Okay, so a radius length equals 5. So we would know, therefore, that the equation of that is x squared plus y squared equals 5 squared, or x squared plus y squared equals 25. Okay. Now, we have a couple of lines, 3 lines drawn in here. Let's start with line A. Line A, if you notice, it intersects the circle at 3, 4. Now, it's a little bit off there, but basically you can see it intersects it at 3, 4, and it intersects it at 3, minus 4. So line A cuts the circle at 3, 4, and minus 3. Sorry, and plus 3 minus 4. Okay, that makes sense in a way, because when we sub those numbers into our equation, 3 squared plus 4 squared equals 25. Does that work? 9 plus 16 equals 25. Yeah, that does. So that point is on the circle, and so is this point. I could do the same thing. What's the name of that line, by the way? Just a quick check back to coordinate geometry of the line. That's a line. Now, if we're working out the slope, we wouldn't be able to get a slope. The slope actually isn't defined for that. But if you can see, it's a line that's parallel to the y-axis, and it goes through x equals 3. So actually, that's the name of that line, is x is equal to 3. So line A has equation x is equal to 3, which is a weird equation for a line. Normally have y's in there as well, but because this line is parallel to the y-axis and it goes through the same x values all the way along the line, its name is x equals 3. Now, does that make sense? Well, it does actually, because both these points 3, 4 and 3 minus 4 have an x equals 3. So they are on that line as well. Okay, let's look at line B. Line B here is cutting this at, oh, it's harder to see here. It seems to be cutting it at, let's see, about minus 4.5, 2. It's hard to tell that actually, isn't it? And cutting it here at about 4.5, 2, something like that. So I perhaps could have chosen a slightly different, could have chosen a different line. But anyway, minus 4.5, 2. This is the line, if you can guess now, it's parallel to the x-axis. It goes through y equals 2 all the way along the line. Its name is y equals 2. And let's see, 4.5, 2, negative 4.5, 2, and 4.5, 2. I wonder, would they be on the circle if I was to work those out? Do you know, my calculator isn't here, someone's run off with it, but I think we would probably find that that's about 21 plus 4 equals 25. So it's on, they're on the line. So that's an equation of y equals 2, and it cuts the circle at about minus 4.5, 2 and 4.5, 2. Line C here, you can see it cuts the circle here at minus 3, minus 4, and it cuts the circle here at 0, 5. Minus 3, minus 4, and 0, 5. Let's see if we can check whether that, we won't worry about the equation for a minute, we'll talk about that in a minute. Let's just see, would that make sense? Minus 3, minus 4, would that be on the line? Minus 3 squared, on the circle I mean, minus 3 squared plus minus 4 squared equals 9 plus 16, which is 25, yeah. And 0, 5 would be 0 squared plus 5 squared equals 25. Yes, that's true. 0 plus 25 equals 25. Okay, so that's so far so good. Now this line C is actually the line that has equation x minus 2y equals 5. I know that because I chose it from the book as an example to work through. And let's just see, that makes sense. Minus 3 minus 2 times minus 4 is minus 3 plus 8, which is 5. And 0, 5 would be 0 minus 2. Sorry, 5, 0. I've done that a couple of times, haven't I? I've done that. I'm sorry, that's probably confusing you. I'm just tired. 25 plus 5. So 5, 0 would be 5 minus 2 times 0 equals 5. 5 equals 5. That's true. So one more word just to use. These lines that cut the circle at two different parts are called chords. Okay, they are lines, you can't really see that very well, they are lines that cut the circle at 2 points. So each of these is a chord. A tangent, if I was to draw one now, a tangent is a line that cuts a circle at 1 point. So there's a tangent, it only cuts a circle at 1 point. This is a tangent. Okay, so let's see, we've got this equation, circle K, we've got the equation x equals 3, we've got the equation x minus 2y equals 5 and y equals 2. So hopefully you can see clearly now the difference between a line equation where all the variables, the x's and the y's, are only to the power of 1. There's no squaring or cubing or anything. And a circle equation where it's x squared plus y squared equals 25. So just a reminder. Now, we can't draw the circle and plot the line every time we want to find a point of intersection. Well, we could, but it just takes a bit longer, and it's good to have an alternate method. So we're going to look at how the algebra method for finding the point of intersection of a line and a circle. And we come across this in algebra anyway. If you've done higher level maths to a point in leaving cert, you'll know that this is called solving simultaneous equations of a linear, which is a line, and a quadratic, which could be a curve or a circle. So simultaneous equations, and the method that we use for solving simultaneous equations of these kind is it's by substitution. So normally when we solve simultaneous equations, we solve them by a process of elimination, but with these we solve them by a process of substitution. So what happens is, these are our two equations. So let's take the first pair here. We've got x squared plus y squared equals 20. X is equal to 10 minus 3y. Hopefully straight away you'll say, oh, that's my circle and that's my line. Now you'll notice that this equation of this line is given in a different form to normal. It's x equals 10 minus 3y. The reason why we do that and we rearrange our equation of our line is because we're going to substitute this expression here for x. So we're going to substitute for x. And what we're going to do is wherever we have an x, we're going to put 10 minus 3y. And I'll tell you why that is. It's because if we have two equations and two unknowns, we can solve them. We could try and do elimination, but it wouldn't work. You can try it yourself if you like. But what would work to make one equation with one unknown, which is much easier to solve, is to substitute this in. So this is our equation that we have of a circle. Instead of x, I'm going to put 10 minus 3y. 10 minus 3y squared plus y squared equals 20. Okay, so 10 minus 3y squared plus y squared equals 20. Now that may not look like it's much use to you. What I can do here is I could do something with this 10 minus 3y squared. Now what I usually do is, because this gets quite big and cumbersome over here, I tend to do it over here on the side. So I work out what 10 minus 3y squared is. 10 by 10, which is 100. 10 by minus 3y is minus 30y. Minus 3y by 10 is minus 30y. And minus 3y by minus 3y is plus 9y squared. So I have 9y squared minus 60y plus 100. And that's my equation. That's what I've worked out, sorry, by multiplying out 10 minus 3y by 10 minus 3y by squaring it. Okay, so if I take that and I put it in where this is, so I've got 9y squared minus 60y plus 100 plus y squared is equal to 20. So all I've done is take that, work it out over here, and substitute it back in. So if I add all these up and take away the brackets, I've got 10y squared minus 60y plus 100 is equal to 20. Now I'd like my equation to equal to 0, so I'm going to subtract 20 from both sides. So I've got 10y squared minus 60y plus 80 is equal to 0. And as you can see, this is a quadratic equation. Now I should have mentioned at the start, this is what I would call a could know question. It's definitely not a must know. It's kind of possibly a should know, and I'll talk to you later about that in class, about what would make it a should know. Getting some marks from this would be good if we could. So 10y squared minus 60y plus 80. Hopefully you can look at that and you can say you could factorize that. I might actually just divide by 10 to start with to make it easier to factorize. So y squared minus 6y plus 8, and I can see my product number is 8, my sum is minus 6, so it's minus 4 minus 2. So y squared minus 4y minus 2y plus 8 is equal to 0. Y by y minus 4 minus 2 by y minus 4 is equal to 0. So y minus 4 by y minus 2 is equal to 0. Okay. Now, if that equals, then I've got that y minus 4 is equal to 0, so y is equal to 4, y minus 2 is equal to 0, y is equal to 2. So what I found is that the y values in the points of intersection are 4 and 2. How do I find the x? I know that x is equal to 10 minus 3y. So, if y is equal to 4, x is equal to 10 minus 3 by 4, which equals 10 minus 12, which is minus 2. So one point of intersection is minus 2, 4. And then when y equals 2, x is equal to 10 minus 3 by 2, which is 10 minus 6, which is 4. So the other point of intersection is 4, 2. So what I found out is that the circle and the line intersect at minus 2, 4 and 4, 2. Okay? So you can see it's a long question. It's a multi-step. That's why I would describe it as a could know rather than a must know, and even as a should know. Okay, I'm going to do one more example. I'm going to take this one over here. So let's go over a page. So we've got x squared plus y squared equals 10. So x squared plus y squared is equal to 10. And my other one is x plus 7y minus 4 equals 0. X plus 7y minus 4 is equal to 0. Hopefully straight away you say that's my circle and that's my line. Now, if you remember, the way that we did this before was we had this equation in a different format. And the format that we had it in was that we had 1x equals everything else. So the first step is to get, the first step is to get either x in terms of y or y in terms of x. So get x in terms of y or y in terms of x. Now, usually if it's 1x, then we'll get x in terms of y. Okay, so I'm going to rearrange this. I'm going to subtract 7y and add 4 to both sides. So what I have is minus 7y plus 4. X is equal to minus 7y plus 4. Actually, that's a bit clunky for using in a minute, so I'm going to rearrange it. So x is equal to 4 minus 7y. I've just changed the order. So I have this, and I have x squared plus y squared equals 10. So what I'm going to do is I'm going to substitute this, x equals minus 4y. So the second one is substitute into the circle equation. Now what I should have said here is use the line equation to get x in terms of y and y in terms of x, and then use that in the circle equation. So Here's my circle. This is a new version of my line. X is equal to 4 minus 7y. So wherever I have an x, I'm going to write 4 minus 7y. X minus 4 minus 7y squared plus y squared equals 10. So again, I'm going to go to a side here, and I'm going to do 4 minus 7y squared, which is 4 minus 7y by 4 minus 7y. So what have I got? 4 by 4 is 16, minus 28y, minus 28y plus 49y squared. So 49y squared minus 56y plus 16. So I'm going to put that back over here. So this is going to go back here. So I've got 49y squared minus 56y plus 16 plus y squared is equal to 10. So I've got 50y squared minus 56y plus 16 is equal to 10. I'm going to try and get it so that I've got 0 on the right hand side. 50y squared minus 56y plus 6 is equal to 0. And now I'm going to try and factorize that. Actually, it does look quite easy because my product number is 300 and my sum number is minus 56. So that's 50 and 6, isn't it? Minus 50 and minus 6. So 50y squared minus 50y minus 6y plus 6 is equal to 0. You could, of course, use your minus b formula to do this, rather than factorizing if you don't like factorizing. But if I do like factorizing, that's where I get to at this stage. There's my factors. So either 50y minus 6 equals 0, 50y is equal to 6, y is equal to 6 over 50, which is really manky as an answer, but anyway, or y minus 1 is equal to 0, y is equal to 1. So y is equal to 6 over 50, which is 3 over 25, or y is equal to 1. So now I've got to find x. X is equal to, from here, 4 minus 7y. Y is equal to 3 over 25. Then x is equal to 4 minus 7 by 3 over 25, which isn't nice at all. 4 minus 21 over 25, which would be 3 and 4 over 25. So one point of intersection is going to be 3 and 4 over 25. I hope I've done that correctly. I've just done it in my head. And 3 over 25. Nasty. And then my other one, y is equal to 1. That'll be much nicer. X is equal to 4 minus 7 by 1 is equal to 4 minus 7, which equals minus 3. So my other point of intersection is minus 3, 1. Okay, so the line x plus 7y minus 4 equals 0 cuts the circle x squared plus y squared equals 10 at 3 and 4 over 25, 3 over 25, and minus 3 minus 1. Okay, I'll leave that with you. Have another look through it, and we'll talk about it again. Thanks, bye-bye.